So today, we're diving into a really critical piece of scientific detective work. It's all about one of Texas's most precious natural treasures, the Laguna Madre. And as you can see, it's an ecosystem that's facing a very serious threat.
To really get why this place is so important, you have to start with this number, 5. The Laguna Madre isn't just some random body of water. No, it is one of only 5 hypersaline coastal ecosystems on the entire planet. That's it. So yeah, this place isn't just a local gem, it's a global treasure, and that makes it incredibly fragile.
And here it is. This is the Laguna Madre, a vital estuary tucked away in the Lower Rio Grande Valley. For so many people, this is a hub for fishing, for recreation, and for nature. It's an absolutely essential stopover for migratory birds. Historically, it's been the source of nearly half of the state's entire commercial fish catch. I mean, we're talking about an ecological and economic powerhouse.
But there's a problem, a big one. It's been officially designated an impaired waterway. Now, that's the official jargon for this place is in trouble. Specifically, we're talking about high concentrations of bacteria and critically low levels of dissolved oxygen. So the big mystery we're going to unravel today is, where's all this pollution coming from, and why is it happening now?
To solve a mystery like that, you need more than just a boat and a few test tubes. This called for a full-on, high-tech investigation. Scientists essentially had to become environmental detectives, using some really cutting-edge tools to trace this pollution all the way back to its sources.
And this was their command center. The official term is cyberinfrastructure, which, I know, sounds super technical. But here's an easier way to think about it. This was the digital crime lab for the whole investigation. It's an incredibly powerful system that pulls together countless clues. We're talking maps, satellite images, water data from all these different agencies and puts them into one single, coherent platform.
The very first step for our detectives was to build an unbelievably accurate map of the crime scene. This whole process is called watershed delineation. It's a little complex, but it breaks down like this. First, they gathered a mountain of data. Then, and this is the really cool part, they used a technique called stream burning to digitally carve all the man-made drains and channels right into the flat terrain map. This made it way more accurate. From there, they could run simulations to see exactly how and where water flows across the land. And finally, they could draw the precise boundaries of every single area that drains into the Laguna Madre. Okay, so with their super accurate map complete, the investigators could move on to the next phase, figuring out the main channels carrying all that fresh water and potentially all that pollution into the Laguna Madre. It was time to line up the suspects. And here they are, our 3 primary suspects. These are the main arteries that funnel water and pollution right into the estuary. You've got the Hidalgo/Willacy Main Drain, which we'll just call the HWMD, the Raymondville Drain, or RVD, and the IBWC North Floodway, or IBWCNF. These are the pathways we really need to keep an eye on.
And here are their rap sheets, so to speak. This gives us a quick side-by-side comparison. You can see right away that the Hidalgo/Willacy Main Drain, the HWMD, is the biggest of the bunch by a pretty wide margin, covering over 1,300 square kilometers. Definitely something to keep in mind as we move forward.
All right, we have our map, we have our suspects. Now the detectives needed to figure out exactly what kind of evidence they should be looking for. I mean, what does this pollution actually look like out there on the landscape?
Well, it turns out pollution really comes in 2 main flavors. On one hand, you've got non-point source pollution. Think of this like a crime scene with fingerprints absolutely everywhere. It's all the stormwater runoff from farms, cities, neighborhoods, all mixed together. It's a real headache to trace back to a single culprit. But then you have point source pollution. This is your smoking gun, a specific, identifiable source like a discharge pipe coming from a factory or a wastewater treatment plant.
And these maps just illustrate that difference perfectly. The map on the left shows you just how widespread those non-point sources are. All that red is urban area, the brown is cultivated crops, it's everywhere. The map on the right, though, it pinpoints the exact locations of those point sources, like wastewater outfalls, and as you can see, the whole region is a mix of both. So let's zoom in on those non-point sources for a second. We're talking about things like fertilizer runoff from farms and general stormwater from cities. But it also includes failing septic systems, which are called OSFs. And a huge concern in this specific region are colonias. These are communities that often lack modern, adequate wastewater systems, which unfortunately makes them a pretty significant potential source of pollution. So the scientists took all of this incredible data. the detailed watershed maps, the land use information, the location of every single potential pollution source, and they combined it with actual water quality samples from the field. After crunching all the numbers and analyzing everything, the investigation delivered its verdict.
And here it is, the big reveal. The study concluded that 2 of our 3 suspects were in fact the primary culprits: the Hidalgo/Willacy Main Drain, the HWMD, and the IBWC North Floodway, the IBWCNF. These 2 watersheds are contributing the most to the pollution problems plaguing the Laguna Madre.
And this slide right here, this is the damning evidence. This table compares the density of pollution sources within each watershed. Just look at the numbers for our 2 culprits, HWMD and IBWCNF. Check out the row for on-site sewage facilities. The IBWCNF has a density of over 6 per square kilometer, while the RVD has just 0.05. It's not even close. You see the exact same pattern for urban areas and wastewater outfalls. The key takeaway is that the pollution sources are way more concentrated in these 2 specific watersheds. And the water samples? They totally confirm this story. This chart shows E. coli bacteria levels. That red line is the safe level for swimming and recreation. As you can see, the average levels for both the HWMD and the IBWCF are way above that line. This is the direct link between that high concentration of urban runoff, wastewater sources, and failing septic systems, and the dangerous bacteria ending up in the water.
And here's one more piece of crucial evidence. This chart shows nitrate and nitrite levels, which usually come from fertilizers and sewage. And guess what? Once again, the HWMD watershed stands out, with levels that are just blowing past the safety screening level. It all corroborates the main finding: multiple types of pollution, all pointing back to the same sources.
So, the science has spoken. The investigation did exactly what it was supposed to do. It identified the primary sources of pollution that are threatening one of the world's 5 hypersaline lagoons. But that brings us to the final, and frankly, the most important part of this whole story. Why does any of this matter? What is actually at stake here?
Let's just ask the question directly. We have the evidence. We know where the problem is coming from. So what are the actual, real-world consequences if the pollution flowing from the HWMD and IBWCNF watersheds just continues?
Look, the consequences are severe. We're talking about direct threats to public health from that contaminated water. We're looking at more and more beach closings, which hits the local tourism and recreation economy hard. It puts an entire commercial fishing industry at risk, an industry that depends on this unique habitat for a huge chunk of the state's total catch. And ecologically, it leads to something called eutrophication. That's where all those excess nutrients create massive algae blooms that literally suck the oxygen out of the water, creating dead zones and threatening the very survival of this one-of-a-kind ecosystem.
This scientific study did its job. It followed the evidence, it laid out the facts, and it pinpointed the problem. But now, armed with this knowledge, the question isn't, where is the pollution coming from anymore? The question is, what are we going to do about it? The investigation is over. The choice is next.